Gpcet-Cse-Cn-Unit. Our next topic is the data link protocol. Here the main purpose of the data link layer protocols are how to transmit the data by using the half duplex and full duplex mechanism in order to ensure that the frames are delivery free of errors to the destination. Some of the points where we need to identify like identification of frame, transmission of frames of any length, the detection of transmission errors, the retransmission of frames which were damaged by an error. Next, we are going to study some of the very important protocols like the channels with noiseless and noisy channels. Coming to the noiseless, where we are going to see mainly three important protocols like unrestricted simplex protocol, simplex stop and wait protocol, simplex protocol for noisy channel. Whereas the noisy channel comes with the stop and wait ARQ, go back and selective repeat. The first one we will go with unrestricted simplex protocol. In order to appreciate the step-by-step development of the efficient complex protocols, we will begin with a simple but unrealistic protocol where the sender and receiver will be always ready to transmit the data. Processing time can be ignored, infinite buffer space is available, where no errors at all. That's why this protocol is also known as a utopia, where the sender and receiver will be sending the frames continuously. The problem with this is how to prevent the sender from flooding from the receiver. The solution is a stop and wait mechanism has to be implemented. In this stop and wait protocol, where the sender is going to make a request, if the receiver is going to receive the data, it generates an acknowledgement. The same similar pattern goes by using the technique of sending the frame, stop transmission, waiting for acknowledgement. If it is received, again go for next frame transmission. The third one is simplex protocol for noisy channel. Majorly it works on three cases, where if the packet losses or the acknowledgement loss or damage. The third one is timeout mechanism. Based on these three, if anything goes wrong, the retransmission to the frames has to take place. Some of the examples is a beautiful representation how the sender and receiver is going to receive the data, and some of the problems where we have been identified and by on the sender and receiver side is the sequence number which has to be adopted. So how the 1-bit transmission of stop and wait protocol works. This is called as the sliding window protocol, where the problem with the elementary data link protocols is unidirectional assumption. It's not a general one. Next we will go with the full duplex approach one. Two separate communication channels has to be identified. If the reversing say happens, it's ready. Our next topic is the data link protocol. Here the main purpose of the data link layer protocols are how to transmit the data by using the half duplex and full duplex mechanism. This is the procedure we are going to use. In order to come over rid of the unidirectional half duplex mechanism, we will go with the piggybacking technique, where temporarily delaying the outgoing acknowledgement so that it can be hooked on to the next out. The third one is simplex protocol for noisy channel. Majorly it works on three cases. The problem is all based upon how the sender and receiver windows work in transmitting the frames from sender to receiver. The third one is simplex protocol for noisy channel. Majorly it works on three cases, where if the packet losses or or the acknowledgement loss or damage. The third one is timeout mechanism. This is one bit sliding window protocol with no error in case 1. Case 2 where the data is lost, again retransmission happens. Third case again data error. Fourth acknowledgement loss. Fifth one is early timeout, outgoing frame out. In the performance of stop and wait protocol, where we are going to use the pipelining technique so that allowing the W frames 10 before transmission. The only problem where we are going to identify is the errors. In this we are going to use another technique with GNP, that is go back in protocol, select to repeat protocol. In the go back in protocol where we are going to send the transmission frames continuously. This is one bit sliding window protocol with no error in case 1. Case 2 where the data is lost, again return. And we are going to see this diagram, how it works with the four frames which are outstanding when the error has been generated. Where the problem with the elementary decoupling protocol is unidirectional assumption. It's not a general one. Next we will go with the full duplex approach one. Two separate communication channels has to be identified. If the reverse thing say happens, how the sender and receiver windows work based on the selective repeating in action. One of the examples of